A rock on Mars is rewriting the definition of life. A black hole is firing jets from the wrong galaxy. The largest structure ever found spans 14 billion light-years. The gravity matrix. Today, we investigate the most extraordinary 12 months in the history of space exploration. In September 2025, the NASA Exoplanet Archive confirmed its 6,000th world beyond our Sun. 6,000 confirmed worlds, and humanity has visited exactly one of them. But the discovery that shook scientists most deeply was not a planet, it was a pattern. A pattern on a Martian rock that on Earth has only one known origin. What the Perseverance rover found in Jezero crater would force scientists to use a word they almost never permit themselves. Biosignature, the chemical fingerprint of life. For decades, the search for life on Mars meant searching for water. We found that. Then we searched for organic chemistry. We found that too. Now, in July 2024, Perseverance found a rock named Chayava Falls, and scientists admit they have never been closer. Closer to answering the question that has haunted every civilization that ever looked up at the stars. Are we alone? And the answer, for the first time in history, might be written in stone. On Earth, these mineral patterns form when microbes interact with iron-bearing rocks near hydrothermal vents. Jezero crater was once a hydrothermal lake. The chemistry matches, the textures match. But science demands more than matching patterns. It demands proof that no non-biological process could produce the same result. That proof may only come when Perseverance's samples are returned to Earth, a mission planned for the early 2030s. In the meantime, Chayava Falls sits in a sample tube on another world, holding a question humanity cannot yet answer. Mars is not the only place in our solar system hiding impossible secrets this year. In early 2025, the James Webb Space Telescope discovered a new moon orbiting Uranus, the 29th known companion of that tilted ice giant. Provisionally designated S2025 Uon, this faint body was invisible to every telescope that came before Webb. It raises an unsettling question. What else is orbiting our neighboring worlds that we simply cannot see yet? Saturn now holds the record for the most confirmed moons in our solar system, 274, as of March 2025. 274 worlds orbiting a single planet. Jupiter, long considered the king of moons, has been dethroned. But the most dramatic visitor to our solar system in 2025 came from somewhere else entirely. Comet 3I Atlas, only the third object ever confirmed to have traveled here from another star system. It made its closest pass to Earth in July 2025, moving faster than any comet born in our own system ever could. It carries material from another stellar system, chemistry that formed around a different sun, in a different corner of the galaxy. For the brief window it was close enough to study, every telescope on Earth and in orbit turned to face it, reading a message in starlight from across the galaxy. While 3I Atlas was passing through, something far larger was being mapped for the very first time. Early in 2025, astronomers announced the discovery of the largest single structure ever identified in the observable universe. They named it Quipu, after the knotted cords that ancient Incan civilization used to record information across an empire. Quipu consists of 68 galaxy clusters, chained together across at least 1.4 billion light-years of space. To place that scale in perspective, our entire Milky Way galaxy is 100,000 light-years across. Quipu is 14,000 times longer than our entire galaxy. It is not a structure in the universe, it is a feature of it. The standard cosmological model predicts that structures this large should not exist. The universe, according to that model, should be smooth at this scale. Cosmologists call this the smoothness problem. Quipu is not smooth. Quipu is a challenge to the entire framework. Dark matter, the invisible scaffolding that shapes cosmic structure, must have organized this chain. But how and when remains unknown. And Quipu is not alone. The cosmic web is filled with structures we are only now beginning to measure, and some of them should not be possible. In 2025, astronomers also found something that defies a different kind of rule: a black hole in completely the wrong location. Every large galaxy we know of has a supermassive black hole anchored at its center. Gravity holds it there, that is the rule. But 3,000 light-years from the center of a dwarf galaxy, 230 million light-years from Earth, something broke that rule. This wandering black hole is not dormant. It is actively consuming material and firing enormous radio jets into the surrounding void. Radio jets of this scale require a black hole actively feeding. Something is supplying it with material, 3,000 light-years from anywhere it should be. The leading hypothesis is that a gravitational encounter, a collision between two galaxies, ejected this black hole from its original home. A black hole, ejected by its own galaxy's violent history, now drifts through intergalactic space, a gravitational predator without a home. Astronomers estimate there could be thousands of wandering black holes drifting through the voids between galaxies, invisible, until they find something to consume. This discovery challenges our assumption that we understand where black holes live, and by extension, how galaxies truly evolve. Every new discovery in 2025 pointed toward the same unsettling conclusion. The universe is stranger and more violent than our models predicted. And yet, in the middle of all this cosmic upheaval, humanity was preparing to do something it had not done in over 50 years. Leave Earth's neighborhood entirely. Send human beings beyond low Earth orbit for the first time since December 1972. NASA's Artemis II mission, scheduled for 2026, will carry 4 astronauts on a 10-day journey around the Moon aboard the Orion spacecraft. For the generation that watched the shuttle era end and Mars rovers land, Artemis II represents something more than a mission. It is a homecoming. Supporting Artemis is a fleet of robotic precursors, Blue Origin, Intuitive Machines, Astrobotic and Firefly Aerospace, all targeting lunar landings in 2026. NASA's Viper rover, designed to map water ice at the lunar South Pole, has secured its ride to the Moon aboard Blue Origin's Blue Moon lander. Water ice at the lunar South Pole is not merely a scientific curiosity. It is the fuel and life support for every future deep space mission humanity will ever attempt. And SpaceX's Starship, the most powerful rocket ever built, is targeting in-space propellant transfer tests in 2026, a capability that could deliver 100 tons of cargo directly to the lunar surface. 100 tons. That is the mass of 12 African elephants, delivered to the surface of another world in a single flight. If Starship delivers on its promise, the moon will not be a destination humanity visits. It will be a place humanity inhabits. But permanent human presence on the moon raises a question that no mission plan has fully answered. What happens to the human body when it leaves Earth's protective magnetic field for extended periods, not days, but months? Cosmic radiation, bone density loss, cardiovascular changes. The moon is not a gentle environment for biology evolved on Earth. India is confronting these same challenges as it prepares for Gaganyaan 1, its first uncrewed orbital test flight, targeted for late March 2026. If Gaganyaan succeeds, India will become only the fourth nation in history to independently launch humans into space. The space age is no longer the domain of two superpowers. It belongs to the entire species now, and the pace is accelerating. In 2025 alone, SpaceX launched approximately 3,000 tons of payload into orbit, the majority of its Starlink satellites. 3,000 tons in a single year. The entire mass of the International Space Station launched to orbit more than twice over. The commercialization of low Earth orbit is accelerating beyond what any government space agency predicted a decade ago. Haven 1, the first private space station, is slated to launch in 2026, opening orbital space to research, tourism, and industries not yet imagined. Meanwhile, Voyager 1, launched in 1977, the year Star Wars was released, continues its journey deeper into interstellar space. In 2026, Voyager 1 will reach 25.9 billion kilometers from Earth, a distance so vast that its radio signals take over 22 hours to arrive. Voyager carries a golden record, music, greetings, the sounds of Earth, addressed to whoever finds it in the darkness between stars. We built a spacecraft, loaded it with our music, and threw it into the dark. That act alone says something profound about what we are. Back in our solar system, the year's most dramatic celestial events are already scheduled, written, in the mathematics of orbital mechanics. On August 12, 2026, a total solar eclipse will darken skies across Greenland, Iceland, northern Spain, and Portugal. From any single location on Earth, a total solar eclipse occurs on average once every 375 years. It is the rarest spectacle in the human lifetime. That same night, the Perseid meteor shower will peak, potentially delivering 60 to 100 meteors per hour across the darkened sky. And on March 3, 2026, a total lunar eclipse will turn the moon blood red, visible across most of Earth's night side simultaneously. The moon turns red because Earth's atmosphere bends every sunrise and sunset on the planet simultaneously, projecting them onto the lunar surface. Every sunrise and sunset happening on Earth at that moment, focused into a single red glow on the moon. You are seeing your own planet's light reflected back at you. These celestial events remind us that the cosmos operates on schedules we did not write, and that we are passengers on a precisely calibrated world. The Kipu superstructure, the wandering black hole, the leopard spots on Mars, each discovery in isolation is extraordinary. Together, they form a pattern. The universe is consistently more organized, more violent, and more biologically active than every previous generation of scientists assumed. And the instrument driving most of these revelations, the James Webb Space Telescope, is still in its early operational years. Webb was designed for a 10-year mission. Its launch efficiency means it may operate for 20 years or more, rewriting our understanding of the cosmos twice over. Every new wavelength Webb examines reveals objects that were completely invisible at other wavelengths, entire populations of cosmic structures hiding in plain sight. The universe's true census is incomplete. Every new instrument, every new wavelength, reveals that we have been systematically underestimating the richness of what exists. In February 2026, SpaceX acquired XAI merging rocket technology, space-based internet, and artificial intelligence into a single entity targeting humanity's cosmic future. Whether that convergence accelerates discovery or concentrates power in dangerous ways is a question humanity has not yet answered, and may not answer in time. These tensions between ambition and consequence have always defined humanity's relationship with the cosmos. We built the Saturn V knowing it might kill its crew. We launched Challenger knowing the O-rings were compromised. The drive to go outward has always carried a cost. Boeing's Starliner, after thruster failures during its first crewed test in 2024, is planning an uncrewed cargo mission to the ISS in April 2026. Rebuilding trust one careful step at a time. The lesson of every generation of space exploration is identical. The universe does not reward haste. It rewards precision, patience, and the willingness to start again. And the universe itself is demonstrating that same patience, having spent 13.8 billion years building structures like Kipu, one galaxy cluster at a time. The atoms in the Chayava Falls rock on Mars were forged in stellar explosions billions of years before our solar system existed. Those atoms drifted through interstellar space, collapsed into our solar system, fell onto Mars, and may have hosted life, before being found by a rover we built in a factory in California. That chain of events, from stellar death to biological possibility to human curiosity, is not a coincidence. It is the universe's standard operating procedure. You are made of atoms that were forged in dying stars. The iron in your blood was manufactured in a supernova explosion before our sun existed. When Perseverance searches for life on Mars, it is stardust looking for stardust, the universe examining its own biography. The 6,000th confirmed exoplanet sits in the NASA archive. 6,000 worlds, each with its own geology, chemistry, and possibly its own biography. Among those 6,000 worlds, statistical models suggest dozens may harbor conditions compatible with life as we understand it, and hundreds more may host life as we do not. Saturn's 274 moons include Enceladus, a world with a global subsurface ocean, hydrothermal vents, and organic chemistry actively venting into space. The conditions inside Enceladus's ocean are nearly identical to the conditions around Earth's deep ocean hydrothermal vents, where life thrives in total darkness. We have not yet looked inside Enceladus, but we have sampled its plumes and found hydrogen, carbon dioxide, and complex organic molecules. The universe is not withholding life from us. It may be that we simply have not yet looked in enough of the right places. The interstellar comet 3I Atlas carried organic chemistry from another star system through our solar system. It did not stop, but it left a question behind. If interstellar objects carry organic chemistry between star systems, then the building blocks of life may be universal, scattered across the galaxy like seeds on the wind. That hypothesis, panspermia, remains unproven. But every year, the evidence that chemistry and biology are cosmic phenomena grows stronger. And the James Webb Space Telescope's newly discovered 29th moon of Uranus reminds us that our own solar system still holds secrets we have not yet found. William Herschel discovered Uranus in 1781 and tried to name it George, after King George III. The universe declined the honor. 244 years later, Webb is still finding new members of the family Herschel first introduced to science. This is what space exploration actually is, not a series of missions, but a single unbroken act of curiosity stretching across generations. The Artemis II astronauts who will circle the moon in 2026 were children when the last humans left it. They grew up carrying that absence. When Orion swings around the moon, its crew will see something no human has seen since 1972. The full Earth, small and alone, hanging in absolute darkness. That image, Earth as a small blue marble against infinite darkness, changed how humanity thought about itself in 1972. It may do so again. Carl Sagan described that image as a mote of dust suspended in a sunbeam. Every discovery of 2025 makes that description more accurate, not less. And yet this mote of dust produced the Perseverance rover. It produced JWST. It produced the curiosity to ask what those leopard spots mean. The universe has been running its experiments for 13.8 billion years. We have been running ours for about 400. The gap is closing faster than anyone predicted. In the last 12 months alone, we found the largest structure ever mapped, a black hole that broke the rules, a rock that might mean we are not alone, and a comet carrying chemistry from another star. And we did all of that while preparing to send humans back to the moon, launching the first private space station, and confirming our 6,000th world beyond our sun. The pace of discovery is not slowing. JWST is still young. Vera Rubin Observatory is coming online. Euclid is mapping dark matter across billions of light years. Vera Rubin will image the entire southern sky every 3 nights, cataloging billions of objects, tracking dark energy's evolution, and catching transient events that no previous survey could follow. Every 3 nights, a complete portrait of the dynamic universe, supernovae exploding, asteroids moving, gravitational lenses shifting, dark energy slowly accelerating everything apart. Dark energy, the force driving the universe's accelerating expansion, remains the deepest unsolved mystery in all of physics. We know it exists, we do not know what it is. The DAISY survey's latest data suggests dark energy may not be constant. It may be evolving, changing its behavior across cosmic time, which would shatter the standard model of cosmology. We may be living through a revolution in physics, as significant as the moment Einstein replaced Newton. The instruments are in place, the data is arriving, the cracks are widening. This is not a failure. This is science working exactly as it should, reality pushing back against our best models, demanding something better, something truer. Every discovery in this extraordinary year, from leopard spots on Mars to a superstructure spanning 1 billion light years, points toward the same conclusion. We are only beginning. If these discoveries left you staggered, share this with someone who still looks up at the sky and wonders. The universe is not finished surprising us, neither are we.